Chapter 5 gets into some basic database concepts. Databases are valuable behind-the-scenes constructs that impact a lot of business functions. They not only can hold information about customers and sales, but they can also be a driving force behind dynamically created websites. Let's start off with some terminology and then dive into some of the places you can use databases. Let's preface this discussion by saying that most databases in use today are relational databases, and this discussion will go over the basics behind relational databases. Non-relational databases also exist, but are used more for unstructured or semi-structured data. We'll see what the difference is between the two in just a bit. Relational databases are much like Excel spreadsheets. They have tables with rows and columns, and data can be categorized using the column headings as a guide, or new columns can be created for data that doesn't quite fit any of the categories already present. In databases, rows and columns go by different names. In a database, a column is called a field, which really is a category, like a name, address, zip code, or phone number. A row is called a record, or a collection of fields. A customer's record would consist of fields like their name, address, zip code, and phone number. A collection of records is a table, just like it would be in a spreadsheet. Databases usually have multiple tables, each one focusing on a specific topic or subject. The relational part of a relational database comes from the fact that tables are related through keys. A primary key is a field that uniquely identifies a record. For a customer table, for example, it's possible that you have two people named Terry Hogan living at the same address. Terry could be both a man's and a woman's name, or one of the Terry Hogans could be a junior or a third. To differentiate them in a customer table, we might give them a customer ID. Your student ID is an example of a primary key in the school's database. Your social security number is also a primary key. Your Food Lion MVP number, your Best Buy rewards number, and even your phone number could also be used as primary keys for some databases. In this example, we have three tables, each with their own primary keys: email num, student number, and visit ID. These keys are used to create relationships among the different tables. In the email table, we have different email messages, all differentiated by an email num. The subject or sender of each email is noted by the student number in that table. It's much more efficient to have just the student number in the email table rather than having the student's whole name here. For one, it cuts down on storage space required for this table. Additionally, it makes name changes much easier. If one of these students were to change their last name, making the change in one place would make sense, versus finding all the instances of the old last name in a bunch of different tables. Finally, it cuts down on the potential for error. If for each email we typed out the student's name, there's always the chance that we typed the student's name incorrectly, which could then result in having an entry for Terry Hogan with a Y, as well as Terry Hogan with an I. When you use a table's primary key in a different table, like we see in the email table and the office visit table, that primary key is referred to as a foreign key in those tables. The student number in the student table is a primary key, but the student number in the email table is a foreign key. It's still the same key, it's just referred to by a different name based on what table you're talking about. A database contains data organized in tables, but it also contains data about the data, or metadata. Metadata defines a table's structure and contents. For the email table, metadata may describe the fact that the email num field is an integer value, or the date field must list a 4-digit year. For the student table, the metadata may require that student names are always capitalized, or student numbers always have to be at most 4 numbers long. Databases are managed by a database management system, or DBMS. Just like a document is edited by a word processing program, a database is created, processed, and administered by a DBMS. Many people conflate the terms database and DBMS, but it's important to note that one is a file and the other is a program that manages that file. Access, Oracle, and DB2 are examples of a DBMS that you might hear about in industry. A DBMS accesses data in a database using structured query language, or SQL, which is pronounced SQL. SQL statements are more like English statements as compared to other programming languages where statements are often in brackets and end in semicolons. You may hear SQL referred to as a fourth-generation language because of its ease of use. Database applications are what most people see when interacting with a database. Most people don't even realize they're working with a database. Some people that work with data entry are using a database application to enter things like customer names and account information. But database applications can take many forms. Every time you're shopping on Amazon or browsing through a movie list on Netflix, you're using an application that interfaces directly with a DBMS. That DBMS uses SQL to check a database to see how much that vacuum cleaner is and how many are in stock, or who stars in that movie you're trying to watch and how many people liked it. If relational databases rely on relationships to make data useful, then non-relational databases don't have relationships. In fact, they don't even have tables. Non-relational databases are used in cases where you have data that can't be categorized easily, like tweets or images or Facebook posts, or when you have large data sets that you may be able to partially categorize, which may be the case when talking about big data. In those cases, a different scheme of parsing through data is used, which goes well beyond the scope of this chapter. If you're interested in seeing what these are all about, look up information on Hadoop and NoSQL to get started. And that's Chapter 5.